When you imagine the future, some things that might come to mind are flying cars, teleportation pods, human-like robots that live among us, and plenty more. Some of these thoughts can sometimes just be our imaginations or Hollywood taking over, but this video is going to cover actual things being worked on in science and engineering that will affect the way we live and even change the world. No one can predict exactly what the future holds, but we can look at emerging technologies, where science is headed, and plenty more to get a good idea of what's in store. So let's dive in. Decades ago, the internet and personal computer were not a thing, and now we've come to a point where without them, for many of us, our life would feel empty. We know that many people spend the majority of their day on some form of a computer, but imagine having even more access to information, entertainment, and more. And this brings us to augmented reality. You've probably all heard of virtual reality, and imagine a time where you'll be able to immerse yourself in whatever world you want. But augmented reality is a buzzword you don't hear as much, which has real potential to change how we view and live in our own world. Imagine being able to visit another country and you see a street sign in a different language, but your contact lenses translate it as you look at it, but without the need for a phone. Imagine having a hearing aid where you could talk to someone who doesn't speak your language and it will translate what they say in real time. Augmented reality has the ability to knock down the language barrier for us. While virtual reality blocks out real reality, augmented reality is about merging the real world with computer-generated images to enhance our experience, and this will completely change how we work, explore, shop, and live our lives. You could visit some big tourist attraction like a museum or landmark and could get a virtual tour where information on different objects and locations would pop up as you walk by them, because by GPS the contact lenses would know your location and what's nearby. You could see sports statistics as you watch a game, or soldiers can get real-time updates on instructions, enemy locations, and plenty more via things like drones flying above the battleground. This could also improve how we train medical students, where 3D visualization and hands-on practice is crucial. To prove that this really works, one company made an AR system for trainees who assemble aircraft wings, and with AR instructions, the first-time workers performed 94% better when it came to error rates compared to getting paper instructions. Some issues with augmented reality include getting sensors to recognize objects around you. Computers actually can have trouble recognizing an animal versus a human, for example, whereas for us it's more natural. We could put like a QR code on the Eiffel Tower or Mount Rushmore so sensors can recognize them, but obviously it's more ideal for having a device just recognize what is what. But what about GPS that could determine our exact location? Well, the problem here is that it tells you where you are on the surface of the Earth, but GPS has some built-in error and doesn't do well when it comes to altitude. You could walk around a museum, look at a painting, and see its information come up 20 feet too high. But scientists and engineers are working on better and more accurate sensors, better image recognition, location tracking, and more, so this can become our reality. But currently everyone watching this video is probably not doing so via glasses or contact lenses. You're on a smartphone or computer most likely, those things that keep changing, getting updated every day it feels like. Will this stay consistent is the question though, and this brings us to what's in store for the computer. An important concept that goes along with computing is Moore's Law. For those who don't know, this is the observation that the amount of transistors that can go into an integrated circuit doubles about every 2 years. So basically after only 2 years, your computer can get twice as powerful or reduce in size and so on. This rise in computer power is what has fueled the economic growth of the past 50 years and allowed us to be able to do everything we can from a laptop. And at this rate, it's just a matter of time before computers can exceed human capability by how much power we can put into a very small amount of space, right? Except for there's one thing. Moore's Law is going to end sooner rather than later, and it's already slowing down. This would cause us not to have new technology updates as quickly and could put a halt to Silicon Valley and severely harm the economy. Something has to replace it and soon, and that depends on the laws of physics. We can now make transistors that are a few nanometers. There are billions of these in your computer which basically create the ones and zeros that make it work. The more there are, the more powerful the computer. And soon they will be so small that quantum theory takes over and electrons leak out of wires, so they won't be able to become smaller after that. One possible replacement for these chips is transistors made of individual atoms, which is a potential in the advancement of nanotechnology. Transistors simply allow you to control the flow of electricity in a circuit. One replacement could be a single molecule made of specific chemicals that have a quote valve that can cut off the flow of electricity or allow it to flow. The source, gate, and drain you see here match the 3 prongs from the other transistor image. These 3 things are what make the transistor operate and conduct or shut off the flow of electricity. This right here is a molecular transistor, and it actually already exists and companies have made them. But properly wiring everything and mass producing them is another story, which is why they aren't in your electronics right now. Another type of computer being researched is the quantum computer, but be aware that these are not meant to replace computers we use every day so we can stream movies much faster. They will be used mainly by big companies and the government due to what they can do better than a normal computer, so don't expect a quantum phone or laptop or anything like that. To demonstrate the power of this, one company used GPS data from 10,000 taxis in Beijing to create an algorithm that calculated the fastest route to the airport. This would have taken a classical computer 45 minutes to solve, and it took the quantum computer a fraction of a second. And another reason for the research is so the government can break cryptographic codes of enemy nations. Solving cryptographic puzzles is basically just solving a math puzzle by searching for a specific key, which is a very large number that has distinct factors. Quantum computers could find these keys much faster. And there are more applications, such as being able to search through very large databases like everything in Google's database, as well as calculating the behavior of atomic scale objects. The cool thing about quantum computers is that they actually use the theories of quantum mechanics. You may have heard things like you cannot know the position and velocity of a particle, or Schrodinger's cat being alive and dead at the same time, and all that stuff which just sounds weird, but this is all the heart of a quantum computer that produces actual results. Who knows what problems they will solve, but there are some things quantum computers will be able to do in minutes or seconds that a classical computer couldn't do in a lifetime. So the end of Moore's Law could be detrimental to the economy, but there are solutions being looked at every day. But now what about robots becoming more intelligent than humans and taking over various jobs? This brings us to the future of artificial intelligence. One thing to note is that computers are very good at some things, but also bad at others. Although they keep getting smarter, computers are not as smart as you probably think. There are robots already out there that can walk around, bring you something you asked for, talk to you, and more, like this robot built by Honda, but they have the intelligence of an insect. They might bump into something and continue to do so, or will pick something up totally wrong and not know it. Now, something you may think of as being smart is like the computer that beat the best chess player in the world 2 decades ago by analyzing millions of moves every turn. But that's all the computer could do. You couldn't use it to build a house or solve a calculus problem. And also the problem with the approach of this computer is that it was programmed with strategy, which means it was limited by how good the software that goes into it is, and it never got better unless they changed the programming. So instead there's the bottom-up approach, where a computer starts really knowing nothing about whatever it wants to be good at, like let's say chess. But it plays and learns just like us. It's simply programmed to learn through trial. And it becomes better and better to a near superhuman level if programmed well. This is the foundation of artificial intelligence. One application of this we'll probably see is robots that can change shapes to perform tasks that are unwanted by humans or just crucial to constantly perform. Maybe a robot is walking along a wall and it needs to go through a small hole. It could change its shape properly to fit through and then reassemble on the other side. In the past, there have been bridges that have collapsed due to age and wear, which caused some deaths and dozens of injuries. Well, we might have robots constantly crawling our bridges, tunnels, power stations, and more, so that they can expect what is wrong and potentially make repairs when needed. In the future, we will probably still have human doctors and surgeons, but a lot of visits to the doctor might be able to be done from home, where you can look at a screen in your home and see what looks like a real person who asks you questions. Based on what you say, it decides what to ask next, and it could even examine your body with a portable MRI scanner. It can analyze information from your bathroom and clothes through the use of sensors to better diagnose anything that may be wrong with you. If something is really wrong, it will tell you to go to the hospital where human doctors can work on you. And when it comes to surgery, robots may be able to perform very delicate operations, whereas a human might have shaky hands or limited accuracy. However, a professional surgeon would still probably operate the robot. And through the internet, a surgeon could even operate from somewhere else in the world. The good news though is that robots will probably not be taking over in the near future, and it's because of 2 flaws in computers. One I mentioned earlier is that they have trouble with pattern recognition, and 2 is that they lack common sense. In one book I read to make this video, which I'll talk about later, the author states that because of these limitations, it will be hard for robots to replace professions that involve pattern recognition, creativity such as trying to make people laugh, or just basic common sense. One example is, let's say, garbage collectors, because they need to recognize garbage bags, place them properly, and maneuver around obstacles. Same goes for something like police officers. You might see in the movies robots that keep us safe, but police officers have to make complex decisions, decide what a suspect might do next, and more that is far beyond what a computer can currently do. The jobs more at risk are ones that involve doing something relatively simple over and over. If you're a low-level broker or accountant, for example, it's possible a computer could do your job way easier. I mean, we already don't need a travel agent because we can easily buy a plane ticket online. Also, stockbrokers who only provide basic advice have lost jobs due to online trading, but those who give wise investment advice will continue to be in demand. It's all about maintaining skills that robots and computers cannot easily do. Then plenty of people believe that computers might get to a point where they're truly smarter than us, where they can make complex decisions, make goals and plans, and even create smarter versions of themselves in which we are left in the dust as they use up Earth's resources and even explore the universe. This is known as the singularity, and no one knows if or when it will happen. Some predict in 2030 a computer will be 1,000 times more powerful than a human brain, while others predict these technologies will merge with us as humans and allow us to live longer and healthier lives. One roadblock to the singularity is that as hardware has increased exponentially, there's no telling how software will improve over time. Technology has allowed us to etch smaller transistors onto a wafer that makes our computers smaller and more powerful. But when it comes to writing code that AI runs off of, it's about people sitting down and making something that works, and who knows when the next groundbreaking piece of code will be written. Now when it comes to computers, technology, and all of that, there's one thing they have to have in order to operate, and that's energy. We can get energy from the sun, wind, ocean, coal, oil, and more, but it's up to engineers and scientists to efficiently convert those things into the energy we need, like electricity. And there's also one potential permanent solution to any energy problems we may have that currently science has not yet figured out. I'll finish up with all this plus space travel, superconductors, and a bit more in the next video. If you like this one, don't forget to comment, like, and subscribe, and I'll see you in part 2.